In this video, we're going to look at the ratio test of convergence for series. In particular, we're going to consider series where the function here, Wn, is a complex valued function, as this is for a complex calculus type of course. So we imagine that this series has the property that the limit of the magnitude of the ratio of Wn1 over Wn as n goes to infinity. So this is well defined, and it's equal to some number L. Now, if L is less than 1, then the series is said to be absolutely convergent. If L is greater than 1, the series is said to be absolutely divergent. If L is equal to 1, then the series is, the test is inconclusive. In fact, the statement of the ratio test is exactly the same even for real valued series. So let's look at a few examples. So suppose we've got this example here. We've got the summation of 1 plus I to the power n over 2 to the power n plus 1. N is going from 0 to infinity. So for the ratio test, so this time Wn is 1 plus I to the power n all over to n to the power n plus 1. So for Wn plus 1, we replace every n by n plus 1. So there's going to be n plus 2. So L is going to be the limit as n goes to infinity of this one. So that's Wn plus 1 divided by, so it's the same as multiplying by the reciprocal of Wn. So 1 plus I here to the power n. Then if we just work these out according to like terms, so this is going to cancel out that, so we're going to have 1 plus I in the numerator, and this is going to cancel out this, so that's going to be 2 to the power 1. So that means we're going to have 2 in the denominator. Now notice that this is now independent of n, so that means this limit, or L, is just going to be the magnitude of this. Magnitude of 1 plus I is root 2. So this thing is 1 over root 2. So since the value of L is less than 1, this is telling us that the series is absolutely convergent. Series is absolutely convergent. All right. So let's see what's going to be the case in part B. So in part B, we have got the summation of this. So that means this is going to be our Wn. So Wn is n factorial squared into 3 minus I to the power 2n all over 2n factorial. So wn plus 1 going to be n plus 1 factorial times n plus 1 factorial. This is going to be 3 minus I to the power 2n plus 2, and in the denominator we're going to have 2n plus 2 factorial. So L going to be the limit as n goes to infinity of n plus 1 factorial, n plus 1 factorial, 3 minus I to the power 2n plus 2, divided by, so this is I here, divided by 2n plus 2 factorial. Then we are going to multiply this by the reciprocal of Wn. So just write it here. So in the numerator we're going to have 2n factorial. Here we're going to have n factorial times n factorial, and then 3 minus I to the power 2n. Okay, now we can start cancelling out. So this is going to be limit as n goes to infinity. N factorial goes into n plus 1, n plus 1 times. Same thing with this one. Then this divides into this one, and we're going to be left with two terms, 2n plus 1 and 2n plus 2. And then this one, just going to cancel that one out. So we're going to end up with n plus 1 squared, 3 minus I squared. In the denominator we're going to have 2n plus 1 into 2n plus 2. Now this is independent of n, so we can take it outside. So it's just going to be magnitude of 3i squared, because by the property of complex numbers, the magnitude of z squared is the same as z squared, and then you take the magnitude of that. Let me see if I'm saying that correctly. So magnitude of z squared is the same as magnitude of z and then squared. And then inside here now we're going to be left with n squared plus 2n plus 1, just expanding that, and then expanding the denominator we're going to have 4n squared, that's this, and this is going to be 4, so it's going to be plus 6n and then plus 2. The magnitude of this squared is just 10, and then the limit of this rational function is just going to be dominated by these two terms here. So that is simply going to give us 1 over 4. So that's 5 over 2. This is greater than 1. This is telling us that the series is absolutely divergent. Series is absolutely divergent. Okay, at this point we are going to give you an opportunity just to try this part C. You can pause the video, then work through it. Then when you continue the video, you're gonna be in a position to compare with our solution. All right, we're now going to scroll down to our solution for part C. We'd like to thank you for visiting our channel and watching this video. We do hope that the material is useful to you. We do, of course, ask you to subscribe and support our channel so that we can do more material like this one. If you've got any issues, any questions that would like to give, ask from us, you can put them in the comment section. All right, for part C, the Wn plus 1 is going to look like this. This is the reciprocal of Wn. Now 2 to the power n will cancel this. This is power n plus 1 here, so we're going to have 1 there, and then n factorial goes into this n plus 1 times, so we're just going to have 3 plus 4i in the numerator, 2 from here, this one n plus 1. This as n goes to infinity goes to 0, of which 0 is less than 1. So this series is absolutely convergent.